Okay, today we heard a lot about switches, infrastructure actually. We heard about time synchronization, also kind of infrastructure if you want. Why I'm saying infrastructure? Because from an HMI vendor point of view, it is a given thing. It's like, you know, a power plug in where always the power comes out. So it's also given that there is power. For us, as an HMI vendor, our horizon ends at the TCP implementation of Microsoft Windows. And this is what I have prepared for you today. We are talking about this area behind the TCP level of Windows upwards in this pyramid or pillar, if we take the new term now. And what is it about the HMI in a substation? When we look into the secondary equipment of a substation, we have this important part on the left side with all the devices, and we have this annoying appendix from the configuration point of view on the right side. The configuration of a protection relay might be straightforward, might be quite easily to copy from one feeder to another feeder or from one transformer to another transformer. On the other side, the HMI gathers all data points that are appearing in these devices need somehow a representation in the HMI. The protection relays, they are protecting our valuable assets, our expensive lines, our expensive transformers. Whereas the HMI is just giving you an overview. The protection relays, they are working 24/7, every second, every millisecond, every microsecond in their life. They are working to protect the assets. Whereas in an unmanned substation, the HMI might not even be switched on. So if you want to get rid of a lot of work, which you have to do, but for a system you very seldom use, you should automate this work as much as possible. If we look into the manual configuration of a substation HMI, so how would the steps look like if I do something like this? So we saw that already from Juergen today. So there's the specification and there is the design phase, commissioning phase. Here we are only in the design phase until the factory acceptance test. And then there is this engineering part, which can take about 40 hours, 80 hours, depending on how complicated the substation is, how much money the utility wants to invest into that work. But in detail, these steps are like, I have to configure the communication part, then I have my database. Then I draw the screens, the single line diagrams, maybe the system diagram, which we saw before. I make some point tests. Maybe I also configure an historian, or I configure reports, trends. And after that, I can do the factory acceptance test. So these are the manual steps. And why else would I do automation except that it's work for an annoying appendix? With automation of that process we saw before, and also this is redundant information because Juergen gave it already, you get standardization into your HMI, you get consistency into your HMI. Same configuration, same substation in one utility, less maintenance work. Easier to recognize for people at the substation when they have to be staffed, the substations have to be staffed. It's easier to come into the application. Of course, if you automate something, you test it before what the output would be. And then the conclusion would be, or the result would be, the reduction in errors or omissions. And of course, as I said before, 40 hours, 80 hours for manual configuration of a substation HMI. If you could do that automatically, I would say, I don't know, maybe with 8 hours you're done, maybe less. And all of that would then, of course, lead into a reduction of the cost. So, how do we think that this works? Actually, we started 2 years ago with the first steps just using the SSD file, or the file that represents the substation level we learned today morning from Jörg. And we took this file, and fortunately there are tools available in this room which provide XY coordinates with the SSD file. So this is actually the output of the system configuration tool, which provides the SSD file. And then we take this SSD file and we import it into the HMI configuration tool. And this is the result of it. So because we have the XY coordinates, all these symbols here are placed at the exact same place as it is here. And then the routing of the lines is done automatically because there is no routing information in the SSD, only connectivity information. And when you run it in the runtime system, then it would look like this. But this was kind of a proof of concept. Can we do it? And how far can we go? And as I said, the SSD file is the substation section. It provides not enough information. Which information is missing is here. So we cannot provide an entire substation HMI just with the SSD file. We need more information because we want to map the signals to the text. So we want to map the attributes to the symbols that represent the circuit breaker, the disconnector. Also control commands is not available in this format. Of course, event list, alarm enunciators, completely missing. Communication configuration is missing because this is the substation part. And there are other parts like IED part and communication part. So this will come if we use the SCD, which we see in the next slide. But what is also missing, of course, and we want to have is a system diagram, as Martin showed us, or the comms screen or communication diagram or network diagram, however you want to call it. And gateway mapping would also be nice. So all this stuff is not there, so SSD was a nice first step, but not enough. So the next logical step is to use the SCD file, so the file that describes everything in the substation. But even then, we have some lacking information, so some things that are not available there. Which are they? So mapping of signals, well, we can do that with the SCD file. But there are some problems even mainly based on how the HMI works internally. For instance, some limits, how to react on limits or thresholds. This is missing. Command control also partly. Part stuff is there, part stuff is missing. Especially, how do you work with select before operate? Should it be an own manual step, or do you want to have that integrated in just in the one-step action of the user? Of course, lists, alarm enunciators, event lists, stuff like this will never be there. But what is there is communication configuration. This is completely available in such a file. So I can configure my, as we call it, driver, the client side of 61 and 50 MMS. I can completely configure that with that information out of that file. System diagram, we heard already today morning. We see all the structure in an SCD file, we see the IP addresses. We can gain information if the SCD includes also the switches, if they have a 61 and 50 server. But why is there partly? It's there because some switches do not have a 61 and 50 server installed or integrated. They rely on SNMP. And we still find a lot of SNMP implementations, and we need to get that information on SNMP into the HMI systems diagram. And gateway mapping, I think this is totally unforeseen in the SCD currently. As I said, there is one thing that is completely possible with the SCD, it's the driver configuration. There is something which was already invented with edition 1 in 61 and 50, but in edition 2, it became kind of mandatory or very popular, and you can use now the client logical node, which gives a lot of information, for instance, to configure automatically all the reporting stuff that is related to the client, to the 61 and 50 client. So, where to get the rest of the information from? So again, this is the process from our starting point, where we started. We have the system configuration tool, we have the file, which is provided by this tool. Then there is something what we call a wizard. It's an add-on to our existing HMI configuration tool. In this wizard, we import this file, but we also import a set of symbols based on the needs or the requirements of the utilities. Because how a circuit breaker looks like for the utilities is always different. It's no standard worldwide. Some rely on IEC, some rely on IEEE, some rely on their own historically grown representation of switches because they remember how it was in the hard mosaic systems, perhaps. So there is this individual symbol set necessary to provide a single line diagram for the needs of the utility. So this is the standard process, but for this additional information we need this signal list. With this signal list we get all the information that is missing in the SCD file. And with that additional information we can then make a 100% mapping of the variables. We can then also create an event list, for instance, or even the content of the event list, because we have the limits, the thresholds, for instance, available. Then we can do alarm management also based on that stuff. Gateway mapping would be possible because signal lists or system configuration tools can provide gateway mapping information into the signal list, and we could also get the system diagram out of that information. But what about usability? Who describes the usability of command control? In this example we see two screens. On the left side we see the overview, the single line diagram of the substation, and on the right side we see a detailed view of one transformer bay. On the left side, it's not possible to send a control command to the IDs, because when you click on that, the right monitor will open and provide you more detailed information, because the concept says you need to have a special level of situational awareness to operate this particular bay. In this case, we see an alarm annunciator, we see the tap changer position of the transformer, we see also the transformer itself, the photo of it, some temperatures, and so on. But there are utilities who want to have a different usability. They want to use the world view technique where they see in a very zoomed out level the entire substation, maybe with decluttered information. So the most important information is available there, and when they zoom in, they get more information, more detailed, cluttered information if you want. And then, for instance, they want to have a contextual menu for their switching commands, like we see it here. So how would you deal with that? This is not available in the SCD file. This is not available in the signal list. So in this case, we still need a kind of a template information based on the requirements of the utility, which are linked perhaps to some information that is in the variable list or in the signal list, which comes directly from the system configuration tool. This can be, of course, but there is other stuff like colors, languages, fonts, I don't know, other screen templates, the position of buttons, the concept of the usability in terms of navigation through this entire application. This is never a part of the 61 and 50 description or the signal list. So we need this building block of a template of this utility example as another, a third information source. And this is recapping that. So we have these three building blocks currently. We have the system configuration description based on 61 and 50 with the single line diagram, driver configuration, reporting configuration, and so on and so forth. Enumerations, maybe the signal list, which gives us more information like the reactions, limits, data types, gateway mapping, very important information from here because we wouldn't ever get it here or here. And then the HMI specific stuff. As I said, usability, switchgear shape, maybe colors, fonts, and so on. And as always, there are different approaches to do that. So I have here an example where we use a system configuration tool, a central tool. And in this process, very simple process in this case, I deleted a lot of stuff here. Everything starts here at the center point at the system configuration tool. The system configuration tool can have already input from the utility or from the TSO, DSO, can have input for the target HMI and then generates a signal list and the SCD file. And then again, this HMI wizard comes into the game and uses its own TSO template stuff, which can be linked with that stuff for the system configuration tool, which provides some advantages regarding a feedback loop, more or less, when you do changes somewhere in that network. And this HMI wizard then generates all the necessary stuff in the HMI tool, in the HMI editor, which then, when you start it, starts this runtime, starts the driver, starts communicating with the 61 and 50 servers, with SNMP maybe, starts the gateway maybe, and yeah, should work as it was described here and here or here. Then there is an example without SCD, because there is still the idea of kind of giving everything in Excel. And in this case, the customer maintains a so-called generic signal list in Excel, which is a really big signal list, where he has, it's kind of a superset of all possible signals, but with no relation to a certain site. It's all signals. And then he has a site-specific lookup table, where then these two information, the two Excel sheets are connected together somehow and create the engineering names for the HMI. Plus, there are vendor-specific SCD files or CID files or ICD files, whatever how you want to call it, but this information comes from the vendor-specific tools, not from a central system configuration tool. And in this case, this wizard here needs to do a lot of work, parsing all the Excel files, big Excel files, working with always changing formats in Excel files. Yes, and put all that stuff together. Again, we have also the Bay templates here, which are imported into the HMI wizard, and the rest actually is the same. We load the HMI editor here and run the substation HMI plus the gateway. How does this currently look like? This is a preview of an early alpha version. It will not look like this when we provide it. On the left side, you see the hierarchy of the SCD file or ICD file. On the right side here, you have the symbol templates, and here you put all that stuff together. There's templates, you generate the engineering names out of the Excel lists, connect it with the 61 and 50 information or the attributes, so that the driver configuration has the right object reference. Also, XY is already there, although in this case it's always 00 because it's not there. Because it's vendor-specific tools which do not provide that, or which do not provide that, or they do not care about it. But it would also be there. And as there is no XY coordinates available in such a configuration, you would need to arrange all your base or boxes or diameters or however you call them in that wizard already. Otherwise, the wizard would place everything on top on the same position. And then you have to rearrange that in the HMI editor again. So you can do that already here. And then you have a nice structure and see everything when it's in the HMI editor. And this is something how the result then could look like with diameters in this case. So, very independently, what are the pros and the cons of using a system configuration tool for automated HMI creation? The plus is, of course, you have a single source. You do everything in one place. However, this requires some work also for the utility. The utility has to put a lot of effort at one time into that work. You can make a strong connection and this feedback loop with the HMI system if the HMI system provides some information, maybe on the basis of XML. so you can have that connection. And very important, the XY coordinates, because this manual shifting of this symbol packages is not necessary then. Of course, all utilities have some information, some lists already, and typically they are in Excel. And you need to get that somehow into the system configuration tool. So then it is migration from Excel to the system configuration tool necessary. But I think it's worth it, because then for later on in the substations, you have the big advantages of saving a lot of costs and time when you create these substation HMIs. And how is this journey going on? So what I've told you now is something where we are currently working on, where we are kind of researching, also developing, but how can the future look like? And the future looks like this. In the past, 6150, from my point of view, was focused quite a lot on the server side, on the gooses, not on the HMI. But there is this new standard which we are currently working on, which will be called IEC 6150-6-2. So it's not the standard which describes SCL, it's the standard which describes how to describe an HMI by the means of SCL. So all the HMI relevant information shall then be encapsulated, perhaps in a file that is called HCD. That's not clear now, but could be. And I hope that then all these building blocks you have seen before, the missing building blocks like signal list and HMI template, could be all part of this HCD file. Still, XY coordinates are necessary. Perhaps they replace it with SVG files, we don't know. And yeah, the outlook is that in 2020 this standard should become normative, or released at least. So it's still some time until that. We will see. Until this standard is ready, we will provide you with wizards as you have seen it before. Where does this come from? And I put this slide into it because normally Alex always asks me if I know about Southern California Edison, who did that already. Now it's already there, so you cannot ask me. This is a slide from Southern California Edison about automatic HMI configuration. So they did that already by the means of SCL. They just extended it for their purposes. It's not normative what they are doing, but it's machine and human readable XML files which they just import and create their HMI at the substation. Bang. And research is going on here. We are currently working on a proposal for a funded research project which deals with automated engineering here. So this is specification engineering, what we saw before, automated engineering, but also considers the validation of what is automatically engineered. Because I said before, it's less errors if you do something automatically, but still there can be errors because it was a human being who made that, and you reduce the possibility of errors if you automatically validate what the output is of this automatic engineering. So this is an idea which we are currently working on. And now I would like to conclude and summarize. The SSD was an important start, thanks to Jörg. More information is needed than what is available in the SSD. So we need the SCD file, we need a signal list, we need HMI template or libraries. The integration of an SCD and the HMI would definitely close some gaps. So if you can run these two tools together, has significant advantages. But as I said, testing is still not covered here. And I hope, and I cross my fingers, that this approach with the IEC 61850-6-2 will be a giant leap towards an automated generation of an HMI system for a substation. Thank you.